Welcome to the project demonstration of wireless power transmission for electrical vehicle using solar with voltage monitoring and battery charging application. So in this version we have added extra feature like battery charging. So we are using the lithium ion 3.7 volts 3200 mAh battery pack for recharging purpose, which is representing the EV vehicle battery pack, and voltage which are going to receive from this wireless power transmission will be measured with help of this voltage sensor directly to this microcontroller at pin number A0, and the battery is charging through this TP4056, which is a inbuilt battery cutoff. Whenever the battery get fully charged, then automatically this will cut off the battery charger to protect the battery from overcharging protection. And here these are the main extra features we have added. Coming to the main operation of this project is, so whenever we want to charge electrical vehicles nowadays, we have the contact base, means we need to plug in the charger connected to the electrical vehicle. So for that we need to get them from the car. Sometimes it's not safe, in that case, in order to charge our electrical vehicles wirelessly, we need to use the wireless power transmission concept, which is based on the mutual induction concept. That's EMF, electromagnetic force, as well as mutual induction concept. So whenever we want to utilize the mutual induction, like electrical magnetic force generation through copper coils, we need to provide the high frequency AC signal. So generally, as we know that from the grid we are going to get 230 volts AC with a 450 hertz of frequency. So that is not sufficient to transfer the power for more distance, because the less frequency is there. So in order to make transfer the power to more distance through wireless, means in order to make like so-called EMF for high region. So for example, so in this one we are demonstrating with 1 inch of distance the EMF will be generated at this around this copper coil. So for that we need to provide 150 kilohertz 12 volts of AC signal. So 150 kilohertz nothing but we need to provide the pulses. So with help of this circuit, so which is an inbuilt IC, will generate the timer signal of 150 kilohertz. So that signal is mainly input to those transistors and MOSFETs inside this, so which is providing the 12 volts AC signal of 150 kilohertz from this 12 volts of DC. So that is provided as input to this copper coil. Then so-called 150 kilohertz AC signal provided to this, we are going to get the EMF around this copper coil. So when this is called as a primary coil. So when we place a secondary coil in this region of EMF, then the secondary coil will get induced and will get the same frequency of 12 volts, and that will be converted into the DC 5 volt with help of this rectifier circuits and receiving circuit. So that is a 5 volt is the input to our charging of the battery pack through this TP4056. So once the battery is charged, automatically this charging circuit will cut off the power supply from coil to this one. There is a LED indication on this TP4056, and parallelly how much of voltage is receiving from this circuit is measured by this voltage sensor, and that will be displayed on the 16:2 LCD screen with help of PIC microcontroller. So this is the main feature. And coming to the components, so to achieve these features we are making use of battery pack, which is rechargeable. So when we talk about the DC, we can store that. So that is a rechargeable battery, so that we can use the renewable sources like solar panel. So whenever the sunlight is not available, the solar panel can't provide the sufficient voltage to charge a battery pack. So then we are going to use a grid. So this is a transformer which will take 230 volts AC input from the grid, and that will be step up down to the 12 volts of AC, and that is the input to this charging circuit. So this charging circuit consists of three stages. So one is a rectification to convert AC to DC, and that is pulsating DC. The pulses will be removed with help of this capacitor, and after that the LED indicator along with another third stage is like a unidirectional current flow. Then we can see the two diodes. So these two diodes purpose is unidirectional current flow whenever the battery is fully charged, in order to protect the battery from overcharging, and also the battery will not flow, the current will not flow to the transformer. So that is the case. We are using the unidirectional current flow purpose diodes, and the same thing on the solar panel also. But in the solar panel, these 4 diodes will acting as a polarity corrector. If we place the solar panel in reverse polarity, so in order to protect the battery from reverse polarity protection, we kept the 4 diodes as a unidirectional polarity correctors in this one. And next, let us see the demonstration. So before demonstration, the main thing is, first of all, we need to keep the battery under charging. So before demonstration, so let's keep the battery charging at least 4 to 5 hours. Till the duration, you should keep the battery under charging for proper demonstration and without any hassles while execution of this project. So let us see the final demonstration, but the main project is driven by the solar panel. So when we want to final demonstration, just keep this solar panel under the sunlight so that we will get sufficient voltage to the battery pack for charging purpose. There we can see the light indication. As of now, it's low intensity, you can see that. So due to the low lighting on the solar panel, we are getting the low intensity from the charging LED. Now this is the on off switch. Okay, so when we on that, the transmitter got switched on. So when we on this, and this is on off switch for the electrical vehicle. As of now, the receiving voltage is 0 volts. So when it is on this receiving coil, there you can see the light indications on the receiving circuits as well as on the TP4056. This red light will turn into the blue light whenever the battery get fully charged. So we can see the receiving voltage on the LCD directly and 0 volts. Right. Okay. Five volt, and when the EMF is reducing its power, then we are getting the less voltage. Okay. Just to monitor the voltage, we are going to on off the switch. But so when the coils are placed nearby, so this power indicated the battery is charging to the wireless technology. Transmitter on, receiver connected in the same region, and TP4046 showing the battery is charging now. So if you want to see the how much of voltage is coming to this coil, there you can see the light. Okay. So in this manner, the wireless electrical vehicle charging will be done to the wireless power transmission concept, along with voltage measuring and auto battery cutoff. Right. Thank you.